I would like to do an example of a limit of a rational function by hand. So let's take a look. My example will be x goes to -3, 2x squared plus 3x minus 9 divided by 5x squared plus 24x plus 27. To remind you, since this is a rational function, if -3 is in the domain, you can just plug it in. So that's always the first thing you try on these things. Try to plug -3 in wherever you see x and see what you get. So everywhere I see an x, I'm going to replace it with -3. So get 2 times -3 squared plus 3 times -3 minus 9. All of that's over 5 times -3 squared plus 24 times -3 plus 27. Let's see. 2 times -3. So I have 18 minus 9 in the numerator divided by 45 minus 27. I'm sorry, minus 72 plus 27. Well, when you compute these, this turns into the dreaded 0 over 0, and that doesn't count. Now, you can always do this with your calculator, but I want to do it by hand and show you the steps. It's very important to see what we're doing here. Now, since x equals -3 makes the numerator 0 and it makes the denominator equal to 0, then x plus 3 is a factor of both the numerator and the denominator. This is basic college algebra stuff. If x minus 3 is a 0, then x minus -3 is a factor. So I can this is going to be easy to factor now. A lot of times when you try to factor, you're searching, you're trying to, a lot of the factoring that's done is trial and error kind of stuff. Well, we already know a factor now. I know that x plus 3 must be a factor in both the numerator and the denominator. So I can write the 2x squared plus 3x minus 9 over 5x squared plus 24x plus 27. The numerator has to equal x plus 3 times something. But you can see, since it's 2x squared plus 3x minus 9, I'll know the other piece has to start with a 2x. Same thing with the denominator. Since 5x squared is in the denominator, I'll know the other piece there has to be 5x. So just a little reminder how this factoring works. Sort of trying to remind you, I guess, of the FOIL method. Yeah, that's what that's called. So you can follow how I get these numbers. I get 2x minus 3 for the other factor in the numerator because I know that 3 times something had to equal the -9. Same thing in the denominator. I know that the pieces have to be 5x for part of it, and the other part, since I have to end up with plus 27, the other piece must be plus 9. So do a little FOIL just to make sure that everything works out if you need to. But knowing that -3 is a 0 was a big deal. That made the factoring almost trivial. So what are we going to do? We're going to cancel out the x plus 3's. Because remember, it doesn't matter what happens at -3, just as we get or are going to -3. So I can rewrite this limit as the limit as x goes to -3 of 2x minus 3 over 5x plus 9. This is a rational function. If I can now plug negative 3 in, I'll have the limit. So let's see what happens if we just try to plug negative 3 in. I get 2 times negative 3 minus 3 divided by 5 times negative 3 plus 9. So I get negative 9 over negative 6, which equals 3/2. And there you have it. I was able to plug it in after I canceled out the whole, if you will. The removable discontinuity. That's what it is. You got to cancel out the removable discontinuity. So let's check this with the calculator just to show you that you can have faith in this method. I'm going to, once again, I'll just put the original function into the calculator. Let me clear whatever's in y1 and y2. And then I guess I'll put it in y1. We had 2x squared plus 3x minus 9 and the parenthesis. Make sure that you have parentheses around the numerator and the denominator, divided by 5x squared plus 24x plus 27. And then go ahead and end the parenthesis. And I'm not going to bother graphing it. I'm going to go right to the table. I'm going to set my table set. I'm going to set the table start at negative 3, which is the target value for x. And I have 1e negative 4 for the delta table. I'll leave it at that. If you look, there's an error, of course, where negative 3 is, but look at the numbers near it. I see negative, or I see for y, I see 1.499. Well, let me paste it in. We'll talk about it when it gets in there. Now let's stretch it out. Of course, the child is crying in the background. All right. Let me circle the important stuff. Use my blue pen as always. Those numbers right around the error, the hole, suggest the answer should be about 1.5. And if you look, 3/2 is equal to 1.5. So to me, this corroborates our answer exactly.